So continuing along the theme that Paul started out with here, we'll be talking about measuring the impact of AR in the enterprise. And so what I'm going to go over is kind of some of our foundations and experience coming from the Daiquiri perspective and give you a little bit of a basis as to kind of how we develop a methodology around this and how we think about measurement as it pertains to impact. I'll talk a little bit about how collecting data and measuring the impact is really part of a larger element of instantiating and growing AR within the enterprise, which is really around narrative development, which is about telling the story of why this is something that people should adopt, and initiating change always requires that kind of narrative development. I'll talk a little bit about how that ties into growth dynamics and gathering the investment resources that are needed, whether that's internally or externally, to be successful at that. And then look at how you can apply that in your context. So first, a little bit of background or why give any credibility to what I have to say. Daiquiri's been around in this space for about 5 years now. As of June 8th, actually, it was our 5-year anniversary. And we've always had an enterprise focus and industrial focus really at the core of how we've looked at the applications of AR. In fact, many of the early materials that our CEO put together when he was out, pitching the first couple folks to join him in this crazy adventure called Daiquiri, were all completely industrially focused, and he pulled them out the other day, and we were all laughing about how closely they represent many of the projects that we're doing right now and many of the things that have come to fruition. We've done hundreds of millions of actual experiences, so people interacting with AR content in one fashion or another, generating a tremendous amount of data. Those are across thousands of campaigns in all different industries. And then the Smart Helmet is obviously our latest addition to that, which brings over a dozen sensors into this environment, helps to measure that impact and create new impacts as far as enterprise use cases, since it is a custom designed device for industrial and enterprise needs, rather than a consumer device being sort of shuttled into the enterprise. And from my perspective, I come from a 30,000 person manufacturing organization with 62 facilities. So while I've been with a software startup and a hardware startup now for a period of time, I certainly have spent my fair share of time in steel-toed boots and standing on floor mats so that my legs didn't fall off after a 12-hour shift. I also built the AR program within that company, and I've also worked on dozens, if not hundreds, of these sorts of deployments. What makes Daiquiri unique, or why our viewpoint's pretty interesting here, I think, is that we produce both hardware and software, and we work across a huge number of industries. So while Boeing gave you a really kind of deep snapshot within the context of one industry, I'll attempt to be a little bit more broad and give you a sense of kind of what are these things that apply across multiple industries or are consistent across multiple industries. And really, foundationally, this is our approach overall, identifying those things that are, on the 80 end of the 80-20 breakdown, and identifying common tasks, common work modalities, methods of work, work locations, things like, picking and packing, or inspection, or electrical maintenance that apply, across, dozens of industries and just about every facility in the world. And so there may always be specific use cases or specific applications where you could look at them and say, well, gotcha, there's this one spot where it won't work, or in exactly these lighting conditions or these electromagnetic conditions, you're going to have challenges. But ultimately, for us to get the device into people's hands and to get people exposed to AR so they can start thinking about the second order applications, those things are not necessarily big blockades or door closers relative to establishing that. So I'll talk a little bit about how we get to some of those. But ultimately, for anyone who's sitting within a large enterprise or anyone who's partnering with a long enterprise, thinking about cost justification is a big part of kind of winning the support that you need in order to bring this into the organization. So thinking first about what is the character of your organization? How do they approach innovation in general? Is there a dedicated innovation group? Is there a set of established metrics across the company that are readily identified as being key drivers or needle movers that you can then design any sort of study or pilot program or measurement that you're going to undertake to line up with? So in Paul's case, he talked about, the cost of error in aerospace is huge, and especially when you start to factor in rework and going back and having to meet those compliance requirements of, in their case, the FAA, but a wide variety of industries are subject to similar requirements. That place where the cost of error spikes in a big way is a great example of how you can line up with that sort of driving justification for the organization. And I think sometimes there's the temptation to always think task time, to always think, total time of assembly. And I think those things can be, deceptively easy to grab onto at first, but maybe don't tell the whole story of the benefits. So how do you, pick out the things that you should focus on and measure and use as a proof point for success? And I use kind of these criteria. So sequencing, sizing, and selection. So first you want to make sure that you're going to be able to demonstrate success quickly. You're going to have a series of kind of what I refer to as small wins that then can build momentum and knowledge base in the organization about what's going to be effective in a program like this. Choosing, problems that match up with that cadence. So not choosing something that's going to take, 2 years before anybody sees initial proof points, or choosing something that requires, a $50 million upfront investment, before you're able to see kind of $1 in terms of return. So thinking about what are the ways that you can kind of balance that and build the cadence that ends up giving you that narrative that you want. And then making sure that you have the backing of the organization is also really crucial to rolling this out. Having, whether it's an individual executive sponsor or it's going to kind of a council or group of executives within the organization, to make sure that people are not only aware of the program, but are bringing up any of their concerns way ahead of time, so that as you're rolling it out, you don't run into some of these unanticipated roadblocks that often come up. So to talk about some specific examples that we've seen, and in this case, since I'm choosing case studies of what not to do, I'm intentionally not going to tell you the names of the companies, but these are 3 organizations that we worked with specifically on programs that are described here. And I'm going to unpack kind of the pitfalls of each. So the first one was within the transportation industry, and it was a guided inspection. And so their activity selection, in this case, picked something that had several hundred steps and had a lot of internal system dependencies. And it happened to also be an internal system that they were overhauling at the time. So you've got the complexity of kind of that internal IT change management project that was going on. You've got the complexity of the scale of the inspection that was selected. And then they also had a primary executive sponsor who ended up getting moved to a different part of the business, during the program. So sort of a perfect storm if you look at those 3 factors of, activity selection that was not necessarily ideal, created a big content burden. Systems integration that was plugging into a system that was changing while they were integrating into it. And then an executive sponsor that also happened to be changing during that period of time. So they certainly, learned a lot from that, but it was something that didn't set up this particular example for success. The second one, this one I see really commonly from organizations that have dedicated innovation programs or innovation departments. And this is where they say the best way for us to evaluate AR or to evaluate, let's say, one component of AR is to do the cross-sectional analysis. Buy 20 different pieces of hardware, pilot 10 different pieces of software, and then come up with a master scorecard or master program to kind of benchmark all of these. And while I think that data, is certainly something that's attractive to all of us, we'd all love to have that finished scorecard sitting in front of us right now. From a rollout or an implementation standpoint, they created essentially over a year worth of research activity or in-lab trialing that didn't have a real high degree of fidelity or transferability to the actual use cases. And while they may have ended up with, a strong scorecard at the end and ready to make a buying decision, by that point in time, I think a third of the pieces of hardware they'd included there were no longer available. Several, new ones were on the market that were not available originally when they started that program. And so as a snapshot, it was only useful for a very short period of time. And this, I think, is really a crucial touch point for making sure that the operation side of the business and the innovation side of the business are working together, and that, if anything, especially for the providers in the room, you look for opportunities to get into the field or get into the shop as quickly as possible rather than kind of staying in that lab environment. The last one's from AEC, so Architecture, Engineering, and Construction, and this was a guided assembly pilot program. And in this case, kind of the key error was the one that I referenced just a minute ago around task time and assembly time. So again, multi-hundred step assembly in this case, which wasn't necessarily a bad activity to select. It was one that was done infrequently and had pretty high learning curve for it. But they chose only to measure task time and total time to completion. And while they did end up seeing a benefit, it was sort of an incremental benefit or maybe smaller than what they had hoped for. And so then when they sat down to do the ROI analysis or to look at kind of what the next steps were, it was very difficult for them to go back to the organization and tell the story of the broader impact because they'd only measured essentially one thing. And so, the net result there was they actually ended up going back to rescope that same program and do the same inspection again, but gathering more data points. Next, I want to talk about a multi-factor study. So the example I'm going to use is from SRI here, but I think it's a really good example of some of the things that I would recommend from a measurement standpoint. And this looked at training, maintenance, and repair. You may have read the paper. AR Mentor was the name of the system if you want to look it up or check that out. But some of the things that I think made it ideal were they used a heads-up and hand-free configuration. And they were able to do this by applying certain hardware constraints up front, and maybe things that they knew weren't going to make it all the way to the active point of use, but that could create enough of the similar conditions necessary to extract and measure these benefits. So in this case, they looked at a 33-step process, so pretty good from a content size perspective, with 11 pages of existing documentation, and it typically took about 40 minutes. They had 3 different conditions, much like Paul's study, so that allowed them to look across several factors plus across the 3 conditions, and you can see some of the initial results here of that multivariate analysis, where if you look at errors, you can see as compared to just using the manual, AR was much more beneficial there and reduced the mean errors as in the Boeing study. But with the manual, with the instructor in the manual, actually it was reduced even further. Now, the outside factor to consider here is what is the cost of the instructor? How many of these instructors do you have? Do they also have to be trained in order to teach this? So, a lot of factors at play, but I think it allows us to ask a really interesting set of questions. Help seeking was about how many times did they take a break during the process and go try to get somebody to assist them. And so if they were all by themselves with the manual, they did that 25 times. If they had the AR system, 7.5, and that was roughly the same as with the instructor. So some interesting comparisons there. And then instructor guidance obviously was the highest when the instructor was dedicated, was there with them throughout the entire process, about half as often, roughly matching up with the times they went for assistance in the case of the manual only. And in the AR condition, and this one's obviously a really dramatic impact, they needed almost no instructor guidance, just 2 times out of the entire operation. And then the total task time, you can see they were not quite as fast as when someone was standing right next to them holding their hand with the AR Mentor, but they were considerably faster, about 50% faster than what they had been with just the manual. So what are some of the things that were done well or could have been done better here? The wearable system, like I said, really good match. Rigorous kind of academic methodology, not surprising coming from SRI, which is a very rigorous company architecture, and they have a set of processes that go around that. And they did collect both the quantitative results that we looked at as well as some qualitative results. So did you find this easier? Did you find this more enjoyable? And I think those are some of the things that can get lost when you're only focusing on the measurability. Because one of the things that I hear very often actually from manufacturing executives is that they see AR as having the potential to improve the quality of life and improve the enjoyment factor that people have relative to their work. So when you have some of these kind of mundane tasks or these tasks that are, they're complex, but not in a way that's really intellectually interesting, the system actually brings this subjective benefit, this qualitative benefit which is that it's more enjoyable for folks to do their work in using it. What were some of the things they could have done better? Pretty narrow task selection. They established, a benchmark for one operation. But if they were to, walk into the facility where this is performed and, run somebody through that and say, okay, now run with it, I think they'd get the common response of, okay, what do I do for the other 11 hours of my shift? Because they wouldn't have had, any of that additional content availability. So there's probably some parallel pathing that they could have done from a content perspective to say, here's how we set ourselves up for rollout. A few of the elements were kind of artificial, and then, pretty small scope overall. So in terms of kind of broad-based measurability recommendations, I would say looking for multiple areas of benefit and measuring them at the same time. So time to productivity. So how quickly does someone initiate productive action? How long does it take? Those are pretty common. Number of errors starting to be more common, starting to be one that really people are seeing a dramatic effect. And then, like I talked about, subjective and transferability are two that often get missed. Also, how artificial the lab environment is or how close you can get to where that task is being performed live is going to have a big impact on transferability, but also believability of that data. When you go to the guy on the floor who's doing the actual operation, if you can say, it was Bob on, the machine number 2 next to you who I ran through this or who used this system, they're much more likely to see that as a proof point that they too can be successful in using this system than if you said, well, in partnership with this university in this, clean environment, we established, some measurable results. So for the case studies that we talked about, these are some of the kind of issues that were baked into the experimental design or to the program design that I think could have been unpacked or potentially at least avoided in the future. So in the case of the first inspection, measuring a broad range of impacts and working with content that was not in flux, I think could have set them up for success. On the hardware and software field testing for the scorecard-based approach, lots of factors, lots of devices, lots of software systems. I think understanding which factors add in a multiplicative fashion or an exponential fashion to how long it takes to run a program or the cost it takes to run a program versus those factors like adding a second task type or adding a few more steps or trying out a couple more participants, which have more of a linear impact on your resource allocation to those studies. And then for the last one, looking at just a single task, we talked about it, but the single factor being measured was a big limiter. So how do you take this into the organization? Look at where your current organization is in its life cycle of testing and adopting these technologies. I think one of the most common things we see is sort of secret programs going on in 4 or 5 different departments where people are not working together. And I've seen that derail scalability where people end up kind of coming to a head when both of those programs are growing and you have to reach a decision point about ownership and whether that ownership is going to be within a single group or if there's going to be some sort of shared ownership or council or committee that brings those together. Looking at program design, learning from the mistakes of others, I think that's tremendously powerful. And then building it into the cadence of your organization. I always say that you want to push that pace, but not be so counter to the culture or pace of the organization that it seems like a wrench in the gears or seems like something that's really countercultural. And you'll be able to tell when you've hit that threshold because they'll go, oh, we'd never do something like that here. And that tells you that maybe you haven't kind of run in parallel to the business process or established the right cadence to that the organization can ingest and handle. Next, I'd say erring on the side of measuring or gathering too much. And I think today's devices, the smart helmet especially, are starting to be really designed for this, where you can have, dozens of sensors running simultaneously. But I think you're always going to end up regretting not having, let's say, set up a video camera or not having, done a subjective report out from the participants, and there are always going to be things that you want to go back and collect after the fact. So really thinking as expansively as you can, and maybe having sensors running that don't pertain directly to the application at hand, but could yield really interesting, time synchronized data as a result later on. And then making sure that you've got the buy-in that you need in order to roll those out. Also, like the SRI study, tremendous amount of information out there that you can synthesize. And there's a methodology within academia around this that I'm sure many of you are familiar with, which is this idea of doing a meta-analysis. So once you've run a couple of studies internally, and you've got to have a few, at least within your industry, if not within your organization, to have that believability and have that kind of story about why this is transferable to your context. But then I think it's tempting to want to run one for every department, or run one across all these different pieces of equipment. But a meta-analysis can help you kind of shortcut that resource need in order to do that. So look at what are the existing studies on those factors, how can you bring them together, how can you establish kind of a more comprehensive picture of the impact. And then, once you've got that measurement of the actual, let's say, task improvement or reduction in errors, then taking that a step further and going to kind of everybody's favorite baseline of return on investment, or as Carl talked about this morning, internal rate of return. It's close cousin. And here, making sure that you've really got a well-worn groove between running the study, collecting the data, and demonstrating that, and that it's already, like I touched on at the beginning, matched up to the cadence of the organization, matched up to things that move the needle. I've seen a bunch of times where people, get through a study, results in a 10% benefit, which would equate to, $20 million a year, but it's a $10 billion organization. And does $20 million a year move the needle enough to take on what's essentially, a fairly sizable change management effort to introduce the new technology? And for a lot of companies, the answer ends up being no. So you've kind of, mismatched those characteristics. So make sure in broad strokes that, you're validating that with the business up front as much as possible. And then from there, leave what's in the lab. I think there's also the temptation, once you give a tool to the operational group or to the frontline worker, to want to continue to kind of measure ad nauseum. And while ambient measurement or passive measurement of that type is super useful, anything that makes it more cumbersome or actually adds to kind of the hidden cost of implementation, I think is going to hurt scalability and hurt the ability to move it across departments and programs. And identifying a way to say, okay, we found a benefit of this type. It had to do with, let's say, error reduction. How can you develop a classification system for all of the tasks, all of the operations, all the pieces of equipment within your organization, so that it's easier to identify other opportunities that share pertinent characteristics with those? So how many inspections of this type with this complexity do you have? How many field force engineers do you have with this set of educational characteristics, who may benefit from this sort of rollout? And that's where, as compared to the big device and software scorecard, I think the scorecard is really helpful to say, in doing my prioritization, when I have 100 ideas about where you could apply this technology, these metrics can be really powerful for picking the best place to start, or at least giving a rough rank order of what those priorities should look like. And that's it for now, and I'll be back later.